Imagine if you could turn back time and relive that special moment once again. Or even better, what if you could slow down time, making a second last for eternity? Sounds like science fiction, doesn't it? But in the world's most advanced laboratories, scientists are already conducting experiments that challenge our understanding of time, manipulating it in ways that seemed impossible just a few decades ago. In the 21st century, while most of us live bound by the relentless rhythm of clocks, an elite group of researchers works tirelessly to unravel the deepest mysteries of the universe, including the very nature of time itself. What you're about to discover will completely transform your perception of reality. Since the dawn of civilization, humans have been fascinated by the concept of time. Our ancestors observed the sun's movement, created calendars, and developed increasingly precise instruments to measure it. But it was only in the last century that we began to understand that time isn't absolute as we once thought. Einstein revolutionized our understanding by demonstrating that time is relative and can be affected by gravity and speed. Today, this discovery isn't just theory. It directly affects our daily lives. Every time you use your phone's GPS, for example, you're depending on time corrections related to relativity, since satellites in orbit experience time differently than we do here on Earth. In ultra-secret laboratories scattered around the world, scientists are already manipulating time in surprising ways. At the National Institute of Standards and Technology in the United States, researchers have built atomic clocks so precise they wouldn't lose a single second even if they ran for 14 billion years, the estimated age of the universe. But this is just the beginning. In revolutionary experiments, scientists have managed to slow down light, which travels at an impressive 186,282 miles per second, until it's practically stopped, creating what they call frozen light. When we manipulate the speed of light, we're essentially playing with the very fabric of space-time. In quantum physics laboratories, researchers have discovered that subatomic particles can exist in two states simultaneously, challenging our linear understanding of time. Through the phenomenon known as quantum entanglement, two particles can communicate instantly, regardless of the distance between them, seemingly breaking the barrier of time. Did you know that time passes more slowly the closer you are to a very massive object? This phenomenon, known as gravitational time dilation, means that your feet are technically older than your head, since they're a few inches closer to Earth's center. In recent experiments, scientists have managed to create conditions where time practically stops. Using temperatures close to absolute zero, -459.67 degrees Fahrenheit, they've managed to slow atoms down to near complete immobility, creating a new state of matter called the Bose-Einstein condensate, where time seems to freeze. Even more surprising is the discovery that time might not be a universal constant as we thought. Some theoretical physicists suggest that time might be an emergent property of the universe, something that arises as a consequence of other more fundamental physical laws, rather than being a fundamental dimension itself. The implications of these discoveries are truly revolutionary. Imagine a future where we could control the flow of time in specific areas, creating temporal bubbles where time passes more slowly. This could revolutionize everything from food preservation to disease treatment. Scientists are already speculating about the possibility of creating temporal stasis fields, where objects or even people could be preserved practically indefinitely. Think about the medical applications. A critically ill patient could be placed in a slowed time zone until appropriate treatment is developed. What if we could use time manipulation to solve the global energy crisis? Theoretically, it would be possible to create devices that harness quantum time fluctuations to generate clean, unlimited energy. Some laboratories are already developing prototypes of quantum batteries that work on similar principles. But while these discoveries open exciting horizons, they also bring profound questions. If we really manage to control time, What would be the ethical implications? Who would have access to this technology? How would this affect our society and our own perception of reality? Imagine a world where different groups of people experience time differently. Some living accelerated zones where decades pass like days, while others opt for slow zones where they can savor every moment to the fullest. Would this create a new form of social inequality? And there are even more fundamental questions. If time isn't absolute, what does this mean for our free will? If past, present, and future exist simultaneously at some quantum level, are our choices really our own? The experiments continue, becoming increasingly bold and sophisticated. In underground laboratories, protected by multiple layers of security, scientists work with technologies that seem straight out of science fiction movies. Temporal containment chambers, artificial gravitational field generators, and particle accelerators that can create tiny black holes are just some of the tools used in this frontier of knowledge. As we advance on this journey of discovery, one thing becomes clear. Our understanding of time is just beginning. Each new experiment, each new theory brings us a little closer to a future where time can be not just understood, but controlled. What do you think about these revolutionary discoveries? How would you use time manipulation technology if you had access to it? Leave your opinion in the comments below, and don't forget to subscribe to the channel for more fascinating content about the frontiers of science. Hit the bell icon to be notified whenever we publish new videos about the most impressive discoveries from the world's most secret laboratories. Remember, the future is closer than we imagine, and perhaps soon, the very definition of near and far will need to be rethought in a world where time is just another variable to be controlled. Until next time.